In this section, we discussed the dispersion of light due to the dependence of the refractive index of a material on wavelength, like that which occurs when light passes through a prism or through water droplets when forming a rainbow. Here we show a ray of monochromatic light passing through a glass prism surrounded by air. When the light enters the prism at the left face, the refracted ray is bent toward the normal because the refractive index of glass is greater than that of air. When the light leaves the prism at the right face, it refracts away from the normal. Thus, the net effect of the prism is to change the direction of the ray, causing it to bend downward upon entering the prism and downward again upon leaving. The refractive index of the glass depends on the wavelength of the rays, which corresponds to different colors. As seen in this table, the effective refractive index of glass for red light is 1.520, and that for violet light is 1.538. This means that if a beam composed of both red and violet light passed through the prism, the beam splits into separate red and violet beams. So the greater the index of refraction for a given color, the greater the bending. Red and violet are at opposite ends of the visible spectrum. Therefore, if a beam of sunlight, which contains all visible colors, is sent through the prism, the sunlight is separated into the full spectrum of colors, as we see here, although, for clarity, we've only drawn the rays for the red and violet light. This separation of wavelengths, or colors, is called dispersion. Another example of dispersion occurs in rainbows, in which refraction by water droplets gives rise to the colors. You can often see a rainbow just as a storm is leaving if you look at the departing rain with the sun at your back. When light from the sun enters a spherical drop, light of each color is refracted or bent by an amount that depends on the refractive index of water for that wavelength. After reflection from the back surface of the droplet, the different colors are again refracted as they re-enter the air. Although each droplet disperses the light into its full spectrum of colors, the observer only sees one color of light coming from any given droplet, since only one color travels in the right direction to reach the observer's eyes. However, all colors are visible in a rainbow because each color originates from different droplets at different angles of elevation, as we see here for the red and violet bands of the rainbow. Therefore, since sunlight contains the full visible spectrum, we can see the full spectrum from red at the top, or outer ring, to violet at the bottom, or inner ring. Double, or higher order rainbows come from multiple reflections within each raindrop.